Welcome to SUNY New Paltz CAD Resources. This channel will hopefully help you learn the Rhino 3D software and complete the weekly homework assignments for CAD 1. Let's get started. So in this video, we're going to be replicating this 3D printed part, but I really want to talk about two different approaches that will be helpful when you're doing your cube replication projects: additive modeling and subtractive modeling. There are times when either one of these approaches will be better or worse in any given situation, so it's good to think about both of them when you do this project. An important aspect of both of these modeling techniques will be mentally visualizing how we would break down our 3D geometry into different 2D views. This will help us to create the geometry we need to either additively or subtractively model our desired shape. We'll start out reviewing subtractive modeling, and then we'll talk about additive modeling. For the subtractive modeling approach, we want to think about creating a solid that we can then remove pieces from to get our desired geometry. So I'm going to start out by measuring the outside dimensions of my object, which we'll use to create that initial solid, which we can call a primitive. So in Rhino, we're going to use the box command and the dimensions that we just measured to create our primitive shape that we will then subtract pieces away from. Now we need to think about the shape of the geometry we need to create that we can use as a cutting object to remove material from this primitive. By viewing our shape from the top down, we can get a better idea of the type of curve we need to create that will be able to extrude into a solid that we can then use to subtract from our cube. I'm going to measure all of these edges just to get a value for each of those distances. For this part of the cutout, you have to use your internal measurement probes on the other side of your calipers. Now that I have my measurements, I'm going to draw a polyline curve which I can extrude into a solid and use as a cutting object. I'm going to use my O-snaps to start my line, and then I'm going to enter the length of each segment of the polyline into the command line. And I'm going to snap to ortho for every line that I draw by holding down Shift to make sure that all of my angles are 90 degrees, which is what my ortho angle is set to right now. We want our curve to be closed so that our extrusion is a solid. That will give us the best results when we do the Boolean operation. Now that we have our curve, I'm going to use the extrude command to make a solid and extrude it to the other side. And then now we can do the Boolean difference command to subtract that part away. Now I need to create a solid shape that I can use to subtract away the parts that are a slightly lower height than the overall height of this object. The distance between my height and the lower height here is going to be 5 millimeters. So if we create a box that's 5 millimeters in dimension, we can use that as our cutting tool. We can draw the box wherever and then move it into place using the move command by selecting one point on the box and a corresponding point on our object. I could use two boxes to cut out the shape, but instead I'm just going to use the scale one dimension command to turn this into a rectangular box that I can then use to cut out both parts of the object at once. Type Boolean difference into the command line, select our object, then select the cutter, then press enter. Now we need to get some measurements of the circles that are going to be cut out of the top of this object. When measuring circles from this type of 3D printed part, we need to take multiple measurements to ensure that we're getting an accurate reading. Especially with the circle around this size, we want to make sure we're getting the widest possible point of the circle. To make the circular cutout, we're going to use the cylinder command, type in the diameter that we measured, and then we're going to type in the height, which is just the total height of our object. And also make sure that you have solid equals yes in the command line. Next, we're going to position our circular cutout. I'm going to use the align tool, doing a left and a top align to get our circular cutout right to the corner of the object. Now we need to measure the edge of the circle to the edge of the object using our calipers. Now we can use Gumball to move our circular cutout over and down in space to get it exactly where we need it to be. just enter those values in after you click on the arrows in the different dimensions. Next, I'm going to copy and paste our circular cutout and then do a right alignment to get it to the other side of the cube. I'm going to use the same value from before, but this time it's going to be negative so that it moves in the other direction. Now we can do a Boolean difference, first selecting our object and then selecting the two cutting circles. We now have our completed object, which we made with subtractive modeling. Let's do it again, but this time we'll use additive modeling. Instead of building a solid that we then subtract away from, we're going to build curves, then surfaces, and add them together using Boolean operations. We need to create curves that when we extrude them will give us the solids we want without making cutting objects. I'm starting my rectangles using my O snaps, and then I'm typing my dimensions into the command line. Sometimes you'll want to enter your dimension as a negative value to get it to go in the right direction that you want. To draw these smaller rectangles, I'm going to start with my O snap and then enter the dimensions into the command line. Now again, I have to make my circular cutout. We enter in our diameter, then we press enter. Next, we need to get our circle into place. First, I'm going to use the align command, and I'm going to do a top alignment, and then I'm going to do a right alignment, which will put our circle right at the corner of our object. Like before, we can do a precise movement with gumball by clicking on the arrows and then typing in our values. Once again, we're using negative values in both the Y and in the X dimension to get our object to move in the direction that we want it to. Next, we're going to copy and paste our circle in place just using Ctrl-C and Ctrl-V. Then we're going to do an align on our copy, we're going to do a left alignment, and then we're going to use gumball again to move this circle into place. Now we have all the curves that we need to create our final shape, so we're going to do curve Boolean to subtract away any inner parts that we don't need. And now we're ready to start extruding our curves. We'll start with these smaller rectangles, and we know from before that these are a height of 10 millimeters. We'll make sure those are solid in the command line. And for this part of the extrusion, you want to select your interior and exterior curves at the same step so that it knows to create the cutout. Now we can just use a Boolean union operation to join our object together. So there you go. That's two separate ways to approach the same problem, and you'll probably find that both of these methods will be useful for replicating the cube project for the midterm. Hope you enjoyed the video and it was helpful. See you next time.